Rahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving Physics 0625 paper for May-June 2025, and currently we are solving the variant paper 4.2, which is a theory paper. But before we start, kindly like and subscribe the channel, and if you find anything helpful in the videos, kindly remember me on your prayers. Acha, when we start to attempt the theory paper of physics, or may it be of biology or chemistry, one thing is very important. You should know the keywords while answering your theory questions. These keywords are very important, and if you use them in your answer, so examiner is chances are that examiner is going to give you full marks for the answer if you've written it correctly. When you can also write your mind out, but if those keywords are not there and just explanation is there, there is a chance that the examiner might not understand your answer completely and you might lose marks. So keywords are very important. And those keywords are mentioned in the marking scheme. Secondly, I encourage you guys to take a printout of the Cambridge syllabus of Physics 0625 as we are solving this paper at the moment, and keep it in front of you while you prepare. Over there, formulas are given, over there, units are given, over there, definitions are given. So try to stick to those definitions, and inshallah, you are going to get good marks. So these things are very important. I am also going to try to attempt this paper with the help of those keywords and everything, so that you get the perfect answer from me. Okay? So let's begin. Question number 1. Figure 1.1 is a speed time graph for an ice skater. Okay. Describe the motion of the skater between T0 and T3. Okay. So between T0 and T3, acha, let me just reduce the magnification so that you can see it clearly. So between time 0 and 3, it would be 3 would be somewhere over here, 1 and 2 and 3 and 4 and 5. So this is T3, basically the area. Okay, so we can see that in a speed time graph, whenever we have a straight line, it means that there is uniform or constant speed. Okay, so if you've got to mention something, the motion of the skater is uniform during T0 and T is equal to 3, or you can also write that the skater is moving with constant speed. Okay. In speed time graph, straight line means constant speed, and in distance time graph, straight line means that the object is at rest. Okay. So moving on to question to part B of the question, calculate the distance traveled by the skater between T0 and T3 seconds. Okay. For a speed time graph, the area under the curve gives you the distance. Okay. Achha, I drew this line before, so you can see that it's a rectangle. So we have this would be 11. And this would be 3. So the width of the rectangle is 3 and the length is 11. So as the area under the graph gives you the distance, so we can see that there is a rectangle over there. So what we are going to do is, so it's 3 and 11. So 33 meters is going to be the distance between the skater travels between t is equal to 0 and t is equal to 3 seconds. Okay, units are very, very, very important. Make a habit of writing the units, okay, so that you don't skip them while you are doing the exams. Acha, state what is meant by deceleration. So deceleration can be defined as negative acceleration. Okay, you might write this and you will get 1 marks for this, or you can write it as that it is rate of decrease of velocity. Okay, so if you write one of these, so inshallah you are going to get the 1 mark over here. Acha, third second part mein, draw a tangent to the graph at t is equal to 9 seconds. Okay, use the tangent to calculate the deceleration of the skater at t is equal to 9 seconds. Okay, now where is t is equal to 9? 8, 1, 2, 3, 4, 5. So this is going to be 9. So I've already drawn a tangent over here. Let's do it again with you guys. How do we draw a tangent? You just take your ruler and draw a line that touches this curve, okay, like this. And here it is, your tangent. I'll just move it up a bit. Okay, so this is your tangent. Now once you have drawn your tangent, as we know that the gradient of a speed time graph gives you acceleration. So when the speed time graph's gradient is curved, we draw a tangent to it, okay, and then take 2 points to take out the acceleration. Okay, acha, yahan pe the 2 points that we are going to take is, number 1 is this one, okay, 10, this one, okay, over here. So this point is going to be 10 and the corresponding point is, let's see, use your ruler, okay, to draw these. Acha, this would be 1, 2, 3, 4, 5. So this is going to be 1 over here. So this point of ours is 10 and 1. Acha, let's take another point. For example, we take this point. This is 8. Okay. And let's look at its corresponding point. So it is going to be 2, almost 2. Okay. Acha, actually it's not 2. It has to be over here. Okay, na? 8 and that line coincides. एक 2 से थोड़ा सा ऊपर है. It's not exactly 2. It's always better with a ruler. Obviously, I just don't have a ruler, so we can take it as 2.2. Okay. So this point is 8 and 2.2. Actually, there always is a margin. For these types of answers, the range is given. Okay, so we have our points 8, 2.2, 10 and 1. So for the gradient, what we do is we use the formula y2 minus y1 by x2 minus x1. So our y2 can be 2.2 and y1 is 1, and x2 can be 8 and then x1 can be 10 then. So this gives us an answer of 1.2 over 2, which is 0.6. Obviously, this is going to be, this negative sign gives you the fact that this is negative acceleration. So 0.6 meter per second square is our answer. Okay. here is the marking scheme. So I was telling you guys that a range of answers would be given. Your answer should lie in between this range. Our answer was 0.60. Over here, the range is 0.50 to 0.70 meter per second square. So our answer is going to be technically correct. Okay, I just wanted to let you guys see what the marking scheme says in this case. Okay. Okay. Moving on to our next question. Okay, the question is from moment of force. Question number 2. Figure 2.1 shows a balanced uniform meter ruler made up of wood. The width of the meter ruler is 2.6 into 10 raised to the power minus 2 meters, and the thickness of the ruler is 6.0 into 10 raised to the power minus 3 meters. Define moment of force in words. Okay, what is moment of force? Moment of force is the product of force and perpendicular distance from the pivot. Since movement को हम we write it as force into distance, so this can be used to write its definition. But over here, perpendicular distance is very important. You just can't write distance. It has to be perpendicular distance, and then you have to write from where? From the pivot. Okay? It has to be written. If you don't write these two words, these were the keywords I was talking about earlier, then your definition is not going to be complete and you are not going to get full 1 mark for this. Okay? So be careful with all of it. Acha. B part states that on figure 2.1, mark the position of the center of gravity of meter ruler with a point labeled x. Label the distance of x from 0 centimeter end of the ruler. Okay. We have to move from here. Acha, whenever they have not mentioned in the question that what is the position of the center of the gravity, then the center of the gravity is the central point of whatever object is being taken, whether it's a plank, whether it's a wooden ruler or whatever. So this wooden ruler is 100 centimeters long. So its what do you say, center of gravity would be at its center. 100 और 0 के बीच में the center would be at 50. ठीक है? So that is the center of gravity, and they've told you to take the distance from the 0 centimeter of the ruler. You can see that over here it's 10. Then over here the distance is 42 centimeters. So a little closer to that would be 50. You know, 42 and 8 markings are left and you are going to get 50. So this is our point that's labeled X, which is the center of gravity of the ruler. Okay? And then what do they ask us? C. Show that the mass of the meter ruler is 0.081 kgs. Achha, in order to find the mass of the ruler, we need to see which of these moments are there and which one are clockwise and which one are anti-clockwise. So this moment is going to be clockwise. Achha, the weight of the mass of the ruler is going to be acting in the downward direction as well. So this is going to be clockwise as well. And if you see this one, this movement is anti-clockwise. So once we've established this, what we need to do is that we are going to write total. You know that according to the law of conservation of momentum, total clockwise movement is equal to total anti-clockwise movement. Okay. So the anti-clockwise movement is F1 D1 plus F2 D2 is equal to F3 D3. ठीक है. So total anti-clockwise movement would be the force 0.34 newtons and the distance of this force from the pivot. So this distance has to be taken. ठीक है. So the distance from 0 to over here is 42. And we can see that this distance is 10 centimeters. So if we subtract 10 from 42, we will find this distance, which is the distance of this mass from the pivot. So 42 minus 10 obviously is 32. ठीक है. Okay. Now we should go towards the clockwise movements. ठीक है. So the clockwise movements basically F1 and D1. This, let's suppose, and this to be F2. Okay, now 0.12 and the distance of this from the pivot would be, this distance is from here to here is 80. ठीक है. And we just need this distance. So what are we going to do is that we are going to subtract this distance, which is 42 centimeters, from 80 centimeters to get this distance of ours. ठीक है. So 80 minus 42 is going to give us 38. ठीक है. I'll just write 80 minus 42 for your convenience as well. Acha. And then we have the weight, and it is at a distance of this weight is going to be at 50 na. So the perpendicular distance from the pivot would be 50 minus 42. ठीक है. So 50 minus 42. Acha, we have to find the mass. ठीक है. So what are we going to do is, acha, if you look over here for F2 and D2, we have the distance, which is 50 minus 42, which is equal to 8. This distance, the perpendicular distance, but we don't have the force, measurement of the force, and we don't have to find the force or weight. We have to find the mass. So we know that W is equal to mg. So we can directly write it over here, or then we can find the force first and then convert it into mass later on. So it's up to you, whatever you want to do. So force 2 ki jagah we can always write mass into 9.8 into the distance, perpendicular distance 8. So when you solve everything together, so the mass comes out to be 0.08 ठीक है. And this can be rounded off to 0.081 as well. Okay, once this is done, let's move to the part 2. Calculate the density of the wood of the meter ruler. Okay, density is given by mass over volume. So we have the mass over here, and we need to find the volume in order to calculate the density. But if you see, though, they've given us all the 3 dimensions. This is 100 centimeters length. This is the height, 6.0 into 10 raised to the power minus 3, and this is the width. Acha, if you look clearly, so these 2 are in meters and the third one is in centimeters. So we need to convert this into meters as well. So this is going to be divided by 100, obviously. So this is going to be 1 meter. ठीक है ना? So now once we have all these values, let's put it in the formula. So mass is going to be 0.081 kgs and volume is going to be 1 into 6 into 10 raised to the power minus 3 into 2.6 into 10 raised to the power minus 2, which was the height. And after you solve all of this, so you are going to get the answer of 519.2 kg per meter cube, and it can be rounded off to 520 kg per meter cube. Okay, so I hope you understood the question. Moving forward. Okay, define momentum. Momentum is the product of mass and velocity. Okay, you are going to write this and you are going to get full 1 mark for it. Okay. Acha. Figure 3.1 shows two toy trains A and B on a track. Okay. The mass of train A is 0.45 kgs. Okay. And the mass of train B is 0.21 kgs. Okay. The trains do not have motors. Okay. Train A travels towards train B and they collide. Acha, both of them are in motion. One is going in this direction and one is going in this direction, and both of them are in motion. Sometimes with the questions related to momentum, one of the object is stationary and one is moving. So in this case, both of them are moving. Let's see what implication this thing has. Okay. Immediately before collision, the velocity of train A is 0.34 meter per second and the velocity of train B is 0.12 meter per second to the left. So one is moving towards the right and one is moving through the left. The trains stick together when they collide. Okay. Calculate the velocity of the trains immediately after collision. Okay. Now we should get one thing straight over here. Since both of them are moving in the opposite directions, so one of them should have a positive velocity and one of them should have a negative velocity. Why? Because we are looking into momentum, and momentum is a vector quantity and it has magnitude as well as direction. So we must have one of these to be positive and one of these to be negative. For example, we might take 0.21 as negative. Okay. And this was something I was telling you, that most of the questions of momentum, one object is stationary and the other heads onto it and collides with it. So in this case, both of them were moving and they were moving in the opposite direction to each other. So this was the catch. You should always try to comprehend the statement before getting started with the questions. Okay, now I was a bit into it. Both of them are moving, so what implication would it have? The implication would be that one of the velocities has to get a negative sign because they are moving in the opposite direction. Acha. Now once what we have to do is we've got to calculate the velocity of the trains immediately after collision. Acha. So according to the law of conservation of momentum, m1 mass 1 into velocity 1 plus mass 2 into velocity 1 is equal to mass 1 into velocity 2 and mass 2 into velocity 2. So mass 1 was 0.45 and velocity 1, which was the velocity before collision for train A, was 0.34, and mass 2 of train, that is of train B, was 0.21, and its velocity can be taken as negative over here and 0.12. Okay. Okay, mass 1 over here was 0.45 and the velocity we still have to find, and mass 2 was 0.21 and the velocity we still have to find. So what we can do over here is that we can just take now they've given us something in the statement that the train sticks together when they collide. So when they stick together, their momentum is going, their velocity is going to be the same. Okay, because now they are sticking together, both of them are moving with the same velocity. ठीक हो गया? So what we are going to do is we are going to solve it over here. 0.153, and this is going to get minus 0.21 into 0.12 is 0.0252, and velocity would be the same for both of them, so we can take the velocities to be common, vt, let's name it, and then 0.21. Okay, so this gives us 0.1098, and this gives us 0.45 into a 0.66. Acha. So this is going to give us an answer of 0.1278, and this is going to give us an answer of 0.66. So 0.1278 by 0.66 gives us the V total, that is the final velocity, to be 0.19 meter per second square. So we are going to write 0.19 meter per second square over here. And the direction, okay, the direction, as you can see that this train was heavier than this train, and when they collide, this train is going to take it with it. Okay, because it was the heavier one. So the direction is going to be towards the right. Okay, that is how we take out the direction over here. Okay. Question number 4, A part. Figure 4.1 shows two metal containers A and B. Okay. Container A has a dull black outer surface and container B has a shiny white outer surface. A and B both contain very hot water at time t is equal to 0. The temperature of the water in each container is recorded every minute. Okay, state which container has the larger temperature change over the first 5 minutes. Explain your answer. Okay, let's go through and look at the question. This container A has a dull and a black outer surface, and this container B has a shiny and a white outer surface. Acha, from our knowledge, we know that dull and black surfaces are poor reflectors and good emitters. ठीक है, and we know that the shiny white surfaces are good reflectors and poor emitters. ठीक है, we know this from our knowledge. Now what is happening over here, both of these containers have very hot water, and they've asked us that which change are we going to observe after 5 minutes. So this being a good emitter of radiation and this being a poor emitter of radiation, both of them will have a difference. The container A has a dull black surface, and dull black surfaces we've established are better emitters of radiation than white shiny surfaces. So as container A is a better emitter, it has a larger temperature change because it's emitting radiations at a much higher rate than the shiny white outer surface one container. Okay, so what are we going to write over here is, let's see how many marks are there for this question. Achha, it's a 2 marks question. So what we are going to write is that container A has a dull and black surface which is better emitter of radiation than the container with white shiny surface, and so as container A is a bitter emitter of radiation, it has a larger temperature change. ठीक हो गया? And inshallah you are going to get 2 marks for it. Acha, the part 2 states that after 30 minutes the temperature of the water in container A remains constant. State in terms of energy transfer why the temperature remains constant. Acha, why is the temperature in the A after 30 minutes constant? It is due to the fact that rate of the energy loss from the water to the surrounding is equal to the rate of the energy gain from the surrounding to the water. That is why the temperature of the water in container A remains constant after 30 minutes. Okay? Because it has given whatever heat it had to give off, and now the outer temperature and the water inside is now are now both at the same temperature. We know the fact that heat always travels from a hot object to a cold object. So it's just like you keep a teacup which contains hot tea in your room, and after some times it will be at the same temperature as the temperature of the room. The surrounding temperature, it will take that temperature. Why does that happen? Because the rate of energy loss is equal to the rate of energy gain from the surrounding. Now they are both at the same temperature. So whatever heat container A, the water of the container A had, it had emitted it off, and now it is at the same temperature as that of the surrounding. So because of that, now it has a constant temperature. Okay? So we can write over here that the rate of energy loss from water to the surroundings is equal to the energy gain from the surrounding. Okay, you will get 1 marks for it, and this is happening because now both of them are at the same temperature, so there is no energy loss now that is happening. Okay, I hope you understood the concept. If not, you can always ask questions in the comment section. Third part, the experiment is repeated without the lids on the container. Okay, state the name of the additional method of energy transfer that occurs. When the lids were on, there was no other way of energy transfer. The only way that remained was through radiation. Okay. But now when the lids are off, there is another method. Since water is involved in this case, so water is a liquid, and liquids transfer energy through convection. Okay. So the other method that will be there for energy transfer when the lids are taken off is going to be convection. Okay. So this is the question. Now moving on to its B part. Shows figure 4.2 shows a metal pan with a wooden wooden handle. Explain why there is a much greater rate of transfer of energy through the metal than through the wood. This has a simple explanation to it. The pot is made with metal, okay, and metals are good conductors of heat as well as electricity. Over here, though we are talking about heat, so the rate of transfer of energy through metal would be more, and as wood is a poor conductor of heat, so the rate of transfer of energy through wood is going to be less. So this is basically the explanation for this. But why does it happen? This happens because the metals have delocalized electrons, okay, and wood doesn't has delocalized electrons over here, because wood is a non-conductor of electricity. Metals are conductors of electricity, though they have delocalized electrons, and due to these delocalized electrons, the transfer of thermal energy is more. Okay. So what we can write over here is, first we have to explain why there is a greater transfer of energy through the metal and not through the wood? It is due to the fact that metal is a good conductor of heat and wood is a poor conductor of heat. ठीक है? This explains the phenomena, but there are 3 marks to it. So you should also write that why is metal a good conductor of heat and why is wood not a good conductor. ठीक है? This is due to the fact that metal contain delocalized electron and so wood doesn't have electrons and can only transfer thermal energy by lattice vibration. Okay, you made a statement over here. You've got to explain that statement as well to get 3 marks. Okay, if you don't explain your statement, so you are not going to get 3 marks. You are just going to get 1 marks for it. This explanation that metals contain to delocalize electrons and wood does not, and because of this fact, wood can only transfer energy by lattice vibration, and metals can transfer energy because of these delocalized electrons. This all has to be written and explained so that you get whole good 3 marks. Okay? Question number 5. Describe an experiment to determine the speed of sound in air. State the apparatus you required, the measurements taken, and how to calculate the speed of sound in air from the measurements. You may draw a label diagram as part of your answer. Okay. Acha, we'll move to the diagram part later on. But this experiment is very important. You should learn these experiments because I've seen this question once or twice before in the past paper questions. So you should know how to calculate the speed of sound in air. Refer to your notes, refer to your books, or wherever you study from the websites, etc. And do remember one experiment to determine the speed of the sound in air. Acha, we are going to be doing this experiment that I'm writing over here. So what do we need? For the apparatus, we need 2 wooden blocks, stopwatch, and a long measuring tape. Okay. And how are we going to conduct the experiment? Now we are going to write that. Okay, number 1, stand at a measured distance. Likely 50 meters away from a large flat wall. Bang the blocks together and listen for echo. Okay. Secondly, what you are going to do is now try to bang the blocks in an even rhythm so that each clap coincides with the echo. ठीक है? Of the previous bang. So that you don't hear the echo separately. From the next bang. Okay. Thirdly, your partner should measure the time for 20 of your bangs. Record the time taken for 20 bangs. And distance from the wall. Okay. Acha, let me see if we have space. Yeah, we have space over here. So I'm going to write the rest of it over here. So once you've measured the distance from the wall and the time taken for the 20 bangs, calculate the total distance traveled by the sound. And as each bang involves the sound traveling to the wall and back, so the total distance would be 2 times from the walls. Okay? So calculate the speed of sound in air using the equation speed is equal to 2 times distance traveled by time taken. And this is how you can calculate using an experiment the speed of the sound. ठीक है? So please write the apparatus used. Please tell the whole procedure. Please write this equation that you are going to use for the calculation, and then only you can get your 4 marks. Otherwise, you won't be able to. ठीक है? As far as a picture is concerned, so you can always use this as your wall. Obviously, I'm not drawing and you can show 2 people standing over here, one with wooden blocks and one with a stopwatch, and then you can just show that the bang that's produced here, and this is what is being calculated, and the distance is also over there. So such a diagram will be suffice. Large flat wall, if your drawing is good, तो और भी अच्छा हो जाएगा. और यहाँ पे you can write at least 50-meter distance, and then you can go along with the answer. ठीक हो गया? So let's move forward to part B of the question. Bluetooth is used to connect a mobile phone to headphones. State the name of the region of the electromagnetic spectrum used by Bluetooth. Okay, Bluetooth Bluetooth uses basically radio waves. ठीक है? And state the speed of electromagnetic waves in there. So it would be 3 into 10 raised to the power 8 meter per second square. Please write the units. Acha, the next question says the frequency of the Bluetooth network is 2.48 gigahertz. Calculate the wavelength of the waves used in the Bluetooth network. Okay, wavelength, frequency and speed can be joined by the help of the formula V is equal to F lambda, where obviously it's used for the Bluetooth network, so it would be an electromagnetic wave. So 3 into 10 raised to the power 8 meter per second square is going to be the speed. Frequency is being given as 2.48 gigahertz, and giga is 10 raised to the power 9. So we are going to convert it into hertz, and then we are going to have lambda. So 3 into 10 raised to the power 8 by 2.48 into 10 raised to the power 9 gives us the wavelength, which is 0.12 meters. Okay. Moving forward. Okay. Figure 6.1 is a full-size diagram of a lens and an image eye of the object. The focal length of the lens is 3 centimeters. On figure 1, mark 2 points with labels F to show the positions of the principal focuses of the lens. And they've told us the principal focus to be 3 centimeter. Let me mark it. So roughly, you can use your rulers. I don't have much precise tools. Again, this is 3 centimeters roughly. So one focal length is going to be, a focal point is going to be here, and the other is going to be over here. So this is 3 centimeters and 3 centimeters. This is the first thing that we've been asked to do. Acha, the other thing is that on figure 6.1, draw 2 rays from the image I to locate the object. Okay, draw the object and label it O. Let me just do it for you. In order to draw these lines so that we can draw the object, we can always draw the object over here, since we know that whenever the image is being formed on the same side as that of the object, on this side of the lens only, and it's upright and enlarged, so it's the object has to be between the optical center of the lens and the focal point of the lens. Okay, so we can always draw this object over here, and then we can draw our lines from it. Okay, since we know that what happens is, okay, so we can draw these lines now, and this line then passes through point F. ठीक हो गया? And then there is another line that passes through the optical center like this. ठीक हो गया ना? And we can balance it like that. And then these lines are drawn backwards, and then you can just see कि this is where your object is. ठीक हो गया? And another line we can make from this point. ठीक है, and it's going to meet where the image is. So you can draw it like this if your drawing is very good, and you can do it without making the object over here. So just do it as well. But I think it's always better to draw the object over here and then extend these lines to see what where the image goes. Okay. So we've completed the second step as well. We've drawn two rays from the image to locate the object, and we've drawn the object and labeled it O. ठीक है? अच्छा. Then the third part states that the object is moved so that it is 6 centimeters to the left of the lens. Okay, now this is 3 centimeters, and another 3 centimeters would be somewhere over here. This is another 3 centimeters. So, okay, almost like it's going to be over here. So this is 6 centimeters. 3 was our position of the principal focus. So this is 2 times principal focus. 3 over here, you will get 2 times principal focus. So the image has been moved over here at 2f. So now what is going to happen? We know that whenever object is at 2f, the image is also at 2f, also formed at 2f, and the characteristics of these images are that it is real, it is inverted, and it is of same size as the object. So they've asked us one characteristics of the image formed when the object is in position. So you may write real, inverted, or same size as that of the object. ठीक है? One of these and you will get your mark. ठीक हो गया? Okay, moving on to question to the B part of this question. Figure 3.6.2 shows a simplified diagram of an eye with rays from a near object. The eye needs correction for long-sightedness. Okay, on figure 6.2, draw the path of the rays inside the eye to show the effect of long-sightedness. Okay. You should always know what long-sightedness is. A long-sighted person would be able to see objects at a distance, but he would not be able to see the closer objects. Okay? And this might be due to the eyeball being too short, or the lens cannot become strong enough. So the rays from the object, closer objects, cannot be converged enough to form an image on the retina, and basically they are focused behind the retina somewhere. So if this is the eye of a person who has the problem for long-sightedness, who needs correction for this, so what is going to happen is that the rays are going to converge behind the retina somewhere. It should converge on the retina, but they don't, and they basically, you can see, are basically converging at a point behind the retina. So this is the problem that we had to state. Okay, they are not focused at the retina. So this is how you do it, and the lens is used to correct the long-sightedness. Describe a suitable lens, lens suitable for this correction. So suitable lens would be a convex lens. Okay, because that is used for long-sightedness, and concave lens is used to cure short-sightedness, or you may draw it like this as well. Okay, both would be correct. Okay, question number 7. State what is meant by an electric field. So electric field is a region where an electric charge experiences a force. A region where an electric charge experiences a force. ठीक हो गया? अच्छा, B part. A plastic rod is rubbed with a cloth. The plastic rod becomes negatively charged and the cloth becomes positively charged. Explain why. So if you've got to explain, it's a 2 marks question, that why did it happen and what was the reason for it. So we are going to write the whole thing that due to friction between cloth and rod, electrons are transferred. Basically, electrons gain energy and are transferred from the cloth to the rod. As there is more negative charge on the rod than positive charge, so rod becomes negatively charged. Okay, and cloth becomes positively charged. ठीक हो गया जी? Write both these things. अच्छा, part 2 states that the negatively charged plastic rod is suspended by an insulating thread. Another negatively charged plastic rod is brought close to the suspended rod. State what happens to the suspended plastic rod. Again, 2 marks question, so you've got to write what happens and then we have to tell that why it is happening. So we know that like charges repel each other and unlike charges attract each other. So since both the rods that were being close to each other were negatively charged, so what is going to happen, that they both will repel each other. So we are going to write this rod, it repels the other rod as both have the same charge and like charges repel each other. ठीक है, you've stated the reason and you've stated what happens as well. अच्छा जी, part C of this question asks us to define kilowatt hour in words. So basically, 1 kilowatt hour is the electrical charge consumed when an device of power 1 kilowatt is operated for 1 hour. ठीक हो गया जी? Moving on, a small lamp illuminates an electric oven. The lamp has an output power of 25 volts and operates for 220 hours in 1 year. The PD across the lamp is 230 volts. Calculate the energy transferred by the lamp in 1 year. Give your answer in kilowatt hour. Okay ji. So energy is equal to power into time. So power basically is 25 watts and time basically is 220 hours. So this is going to give us an answer in 5,500 watt hour, but we need an answer in kilowatt hour. So what are we going to do is that we are going to divide this 5,500 watt hour by 1000. So this is going to give 5.5 kilowatt hours. Okay, so this is done. Calculate the current in the lamp. Acha, current in the lamp can be calculated by the formula V is equal to IR and P is equal to VI. Since we don't have resistance over here, we have power over here. So we are going to use this formula. So the power is 25 watts, and we were given this voltage to be 230 volts. And I we have to find, so 25 divided by 230 is going to give us the current, which is going to be 0.108 amperes. Okay, write the units. Acha ji, 8th question. Figure 8.1 shows a simplified diagram of an AC generator. State the name of the components. As this is a generator, so these rings are going to be called slip rings. Okay. And these points X and Y would be brushes. ठीक है, AC generator में these rings are slip rings and DC motor में these are split ring commutators. ठीक है, so do pay attention to what you are being asked. ठीक है, अच्छा जी, part 2, explain why electromotive force is only induced when the coil is turning. It is induced when the coil is turning because it cuts basically the magnetic field. Okay, and that is why the EMF is induced. So we are going to write that when the coil turns, it cuts the magnetic field and an EMF is induced. ठीक हो गया जी? So this is out of the way as well. Third part states that state one possible change that causes a larger EMF to be induced. If you want a larger EMF, you can do 2 to 3 things. First, you can increase the strength of the magnetic field. This is going to result in a larger EMF to be introduced. ठीक है, or you can increase the number of turns of the coil. And then you can also do this by increasing the speed of the rotation of coil. ठीक है, so these are the 3 things you can use to increase the EMF that's being induced. ठीक है, resistors A, B and A, B, C, D are identical. The current in the resistor A is 2.4 amperes. State the value of the current in resistor B. Explain your answer. Okay, we know that this is a parallel circuit. In parallel circuit, V total is equal to V2 is equal to V3, and for I total for a parallel circuit it's I1 plus I2 plus I3. Okay, if you know this concepts, so you can see that all the resistors have identical, all the resistors are identical, so they would be getting same amount of current. Okay, so if this one is getting 2.4, then 2.4 is going to come over here and it is going to be divided in the two of these resistors, since both of these resistors are identical and are connected together in series. Okay, so 2.4 divided by 2 is going to give you the resistance in these resistors 1.2 ohm and 1.2 ohm. ठीक है. So current in resistor B is 1.2 ohms, and the explanation for this is that total resistance of two identical resistors in series is added together. ठीक हो गया? So moving forward, calculate the current value of current I. So value of current I would be 2.4 plus 1.2 plus 1.2, and it is going to be equal to 6 amperes. This 2.4 is going to go over here as well now. Okay. Moving forward. Three, the reading on the voltmeter is 5 volts. Calculate the resistance of resistor A. Okay, V is equal to IR. V जो है, they've given us to be 5 and current was 2.4. So 5 divided by 2.4 is going to give us a resistance of 2 ohms. Moving forward. Number 9, what is meant by background radiation? So the radiations from natural sources is background radiation. Is background radiation. ठीक हो गया? Okay, let's move on. State one source that makes significant contribution to background radiation. That would be radon gas. ठीक है, and it can also be rocks or building. It can also be food and drinks. ठीक है, and not to forget cosmic rays as well. You can write any one of these. Okay, the beat part states that radioactive isotopes are used in some medical treatments. Radium-223 is an isotope of radium. Radium-223 decays by the emission of alpha particle to an isotope of radon. Complete the nuclide reaction for this decay. So radium is 223 and 88, 223 being its nucleon number and 88 being its proton number. And whenever there is an emission of alpha particle, so the nucleon number reduces by 4 and the proton number reduces by 2. So radon would be 223 minus 4. That is going to give us 219, and 88 minus 2, which is going to give us 86. And obviously over here we have 4 and 2. Okay, so that's how we do it. For an alpha emission, there is a decrease of 4 in the proton number in the nucleon number and decrease of 2 in the proton number. Okay. Okay, what else? Radium-223 is injected into the body to treat specific organ. Okay, explain why the source must be inside the body. Now over here you can see that radium was an isotope which was decaying by the emission of alpha particle to an isotope of radon. So whenever there is alpha particle involved, though alpha particles we know are most ionizing and least penetrating. ठीक है? So it has to be inside the body, otherwise it can be even stopped by a single sheet of paper. So the skin will act as a barrier and outside the body, this won't be able to be act on an organ that is way inside the body. Okay, so this is the basically reason, and if we have to write it in a scientific manner using keywords, so that would be that alpha particles are most ionizing and least penetrating, so they would not be able to pass through skin and target the organs. So they have to act from inside the body. ठीक है, it's a 1 marks question. आपने you've given the explanation and the reason, so inshallah you'll get the mark. Okay, part C. An isotope of technetium is injected into the body to detect cancer in one of the organs. The half-life of this isotope is 6 hours and it decays by emitting gamma radiation. The radiation is detected outside the body. Explain why a source of gamma radiation is used. Acha ji, source of gamma radiation is being used because gamma radiations are the least ionizing and most penetrating. ठीक है, so they would be able to be detected outside the body. ठीक है, when they are inside the body. So this is the basic reason. ठीक है, so we are going to write that gamma radiations are used because they are least ionizing and most penetrating. So they can pass through body's tissues to be detected by the sensor outside the body. ठीक हो क्या? Part 2 states that explain why a source with a short half-life must be used. Obviously, the reason is that a source with the short half-life minimizes the patient exposure to radiation. It's going to finish up real quickly. So minimizes the patient's exposure to radiation. The isotope decays quickly. Quickly reducing the risk of harm to the healthy cells and organ. Okay, so moving on, question number 10. Table 10.1 shows data for planets A, B, C, and D. State and explain which one of these planets is closest to Sun. Okay, the planet that will have a surface temperature to be highest will be that planet which is closest to Sun. So if we look at the options, the surface temperature of planet A is 153 Kelvin, of B is 623 kelvins, C is 53 kelvins, and D is 93 kelvins. So this is the planet which would be closest to Sun because its surface temperature is the highest. Okay. B, because its surface temperature is the highest. Okay, so B part, calculate the surface temperature of planet D in degree C. So this is planet D. Its surface temperature is 93 Kelvin. So if we have to convert something in Kelvin to degree C, we have to subtract, if we need to convert something from Kelvin to degree C to degree Celsius, we have to subtract 273 degrees from it. So this gives us an answer of 180 degrees, negative 180 degrees. ठीक हो गया? So that's how we convert them. And if you have to convert something from degree C to Kelvin, so you've got to add 273 in it. ठीक है? Third part, an object falls through a height of 2 meters on each of the planet in table 10.1. State and explain on which planet the object falls 2 meters in the shortest time. Ignore any effect due to atmosphere. Achha, the time will be shortest when the acceleration due to gravity is highest. Okay, so let's look at our options. Where is the acceleration due to gravity the highest? Okay, we can see over here that this planet A has the gravitational field strength to be 23.0, and if everything else is being ignored, so the object is going to fall with an acceleration of 23.0 acting on it. So we are going to write that it will be shortest on planet A as the time taken to fall will be shortest when acceleration due to gravity is highest. Okay, so in table A, planet A has the highest gravitational field strength, and in the table planet A has the highest gravitational field strength. I'm just going to write GFS for it. Okay. Okay, moving on to part B. Figure 10.1 shows some of the stages in the life cycle of a massive star. Okay. Massive star expands, and then what happens? Whenever a massive star expands, so it becomes a red supergiant. Okay, and then it converts into a supernova. So now supernova में nebula है which contains heavy elements. And it leaves behind black hole or neutron stars. Okay, so this was quite simple and straightforward. Complete figure 10.1 by adding the correct terms that we have already done. State the quantity that the brightness of a supernova in a galaxy can be used to determine. Okay, it can be used to determine the distance of the galaxy from the Earth. Okay, so this brings us to the end of our paper 4.2 of May-June 0625 and 2025. So we are done with it. I hope you found it helpful, and if you found it helpful, kindly like and subscribe the channel, and remember me in your prayers. Take care of yourselves until we meet in the next video. So till then, Allah Hafiz.